Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NAFIIS bin KHARUDDIN, and my supervisor for this research is Sir Muhammad Asrul bin Mustafa. And in this video, I would like to present to you about my research, which titled "The Estimation of Euler Pole Parameter for Sundaland by using the robust filtration approach." Before I go in depth into my research, I would like to tell to you overview about my research. Okay, do you know the Earth's surface that we are living on it are actually moving, and this movement are very small because that's why we cannot feel the movement. And then the movement of the Earth's surface are following the motion of the each tectonic, and even though the movement are very small over a long time, it can affect to the local reference frame, because the accuracy of local reference frames, because the local reference frames such as if for Malaysia is GDN 2000 or my article net is no longer on its original position. So if the surveyor want to do their works, the GNSS will give the coordinates, it will give the wrong coordinates. So to maintain the local reference frames, the Euler pole parameter need to be estimated. So that's why in this study, it's aimed to estimate the Euler pole parameter in for Sundaland in ITR in latest version of International Terrestrial Reference Frame, which is ITRF 2020, by using the robust filtration approach. So the problem statement for my research is the Euler pole for Sundaland. The Euler pole parameter are still not estimated in the latest version of ITRF. So and the next is the robust filtration approach in estimation of Euler pole parameter are still questionable, since there are some method of filtration has been introduced by previous researchers such as Bada, Tau, and limit. And so the aim of this study that has been said before, to estimate the Euler pole parameter for Sundaland in ITRF 2020 by using the robust filtration approach. And to achieve these aims, there are two objectives that need to be done, which is the firstly is to validate the robust filtration approach for estimating Euler pole parameter in ITRF 2020 for Sundaland. And next, the second is to compare the Euler pole parameter value from ITRF 2020 between the Euler pole parameter value from the previous version, which is from ITRF 2014. And then so the significance of my study, which is if the Euler pole parameter value has been estimated, so this Euler pole parameter can be used to maintain the local reference, the accuracy of local reference frame. So if the local reference frame has been maintained, so the surveying agencies such as JUPEM or land license surveyor can determine the accurate position, since the local reference frame has been maintained its accuracy. Okay, and then not wasting time, I will jump to the methodology, which is in my research there are five phase need to be done, which is in the first phase is the data collection phase. In the data collection phase, there are some data such as IGS station data and coast station data, and others data is still need to be collected to be processed the estimation of Euler pole parameter. So the raw data such as cost and IGS data will be processed to tie with the international terrestrial reference frames, and this can be happen in the in data processing phase. And in this phase also the Euler pole parameter can be estimated by using the Euler pole calculator that has been produced by the Ali-Gordozzi. But the problem is the Euler pole parameter in this phase are still exposed with the outliers, too much outliers. So that's why the next phase need to proceed the next phase, which is the filtration process, which is in the filtration phase, the all outliers will be removed in the Euler pole parameter Euler pole parameter value until the remaining errors is the blunders or random errors. And there are four methods that has been used in this research, which is the first is the limit-based method, and then is the tau method, and then the lastly is the combination method, which is the combination method filtration of limit method and statistical method, which is either Barda or tau method. And then next is to validate which filtration method are the best for the Euler pole parameter value. This filtration method will validate by using the root mean square error (RMSE), by using the MAE, or we call it the mean absolute error, and standard deviation analysis, and the number of remaining stations. And lastly, after the Euler pole parameter robust filtration method for the Euler pole parameter has been determined, each Euler pole parameter value will be used to compare with the previous version of Euler pole parameter, which is from the ITRF 2014. And now we move to the main parts of this research, which is the result. As you can see, this is a graph for RMSE and graph for MAE, which is in this graph, the higher value of MAE or RMSE is mean there are more error exposed in this data. And then this is the third graph is the standard deviation of angular velocity, which is the lower value of standard deviation of angular velocity. That's mean the more precise and more stable the Euler pole parameter value. And then this is table of result Euler pole parameter value for each filtration method, and together with the number of remaining stations. And this is table of the comparison between filtration the comparison of the filtration method, which is, as you can see, the combined method, there are no rejection. There are no criteria has been rejected. So that's mean the combined method is the more robust filtration methods for the Euler pole parameter value. So the Euler pole parameter value from the combined method will be used to the second objective, which is to compare with the previous version of Euler pole parameter, that's from the ITRF 2014. And you can see in this table there are no significant difference between both versions of ITRF, and also you can see the standard deviation from the latest from the EPP value from the ITRF 2020 is lower than Euler pole parameter value from the ITRF 2014. And the conclusion for my research is, as you can see, all objective has been achieved, which is the robust filtration method for Sundaland in ITRF 2020 is the combined method. And the next after that, the second is after the comparison between both version of Euler pole parameter, we can get it the Euler pole parameter value from the latest version of ITRF is more precise than the latest previous version of Euler pole parameter. and then it indicates that the Euler pool parameter, this Euler pool parameter value can be used and suitable, can be used to consider suitable to be used in to estimate the velocity within the Sundaland area, and by using the estimated velocity we can use to maintain the local reference frame within the Sundaland area. So that's all from my presentation today. For this video, that's all for me. Thank you.